Hello, PLMS. Today we're going to be working with direct variation. Direct variation is a function in the form y is equal to kx, or k is equal to y divided by x. And that works because if I divide both sides by x, then k is equal to y divided by x. There are two other vocabulary words that you're going to hear interchanged. Constant of variation for direct variation is k is the coefficient of x. So when we're talking about the rate of change, that's always going to be k. Constant of variation is a rate of change, or constant of proportionality. So just get used to hearing proportionality, hearing those words sort of interchange. What is the constant rate of change or slope of the line? We have to look at the scale. So on this particular problem, we've got x, the x is on the horizontal axis, y is the vertical axis, and in between these numbers, that's going to be the numbers 1, 3, 5, 7. So my point is that we're counting by twos, but actually it's a 1-to-1 scale, even though you only see every other number. If I'm going up or on the y-axis, then if this is 6, that makes this 3, 9, 15, etc. So as far as the change is concerned, I'm going to go start at 0. You're going to notice all of the graphs we deal with today go through the origin. That's very important. Again, they all go through the origin. That's the point 0, 0. If they do not go through the origin, then it is not direct variation. So from 0, we're going to go up 3, and we're going to go over 2. Now, why am I picking that point? Because I'm looking at an intercept. I want to concentrate on the line, but I want to look at points that are on the line where it's at an intercept. All of these little dots, those are points on the line, but that's going to be hard to count between, so we want to look at units. So if I go up 3 and over 2, that is my constant rate of change. Also, notice that this ordered pair is 2, 3. This ordered pair here is going to be 4, 6, 6, 9. And this just so happens, look at this, it's going to be y, x. So when I do y over x, then it's 3 over 2. Or 6 over 4. Look at that. That breaks down to 3 over 2. 9, 6. That's going to be 9 over 6. That also will break down to 3 over 2. So the constant rate of change is 3 over 2. Is the total number of pages printed always proportional to printing time? Yes. Because we print 3 pages every 2 minutes. And compare the constant rate of change to the constant ratio. That too is 3 over 2. This is what the equation looks like. Y is equal to, in this case, 3x. Y is equal to 3x. Remember that the equation looks like y is equal to kx. So 3 is the k, or the coefficient of x. So if I start at the origin, look at this graph. It goes through the origin. That's very important. I go up 3 and I go over 1. Look at the triangle. That is where we get the 3. So the constant rate of change is that I'm always going up 3 and over 1, and then the better way to say that is just 3. So that's what it looks like on a graph and on an equation. These are two different examples, proportional versus non-proportional. Proportional means that every time, remember the equation, k is equal to y divided by x. When I divide y by x, or -2 divided by -2, I get 2. And these are points on the line. So -4, -2, 1, 2, 3, 4. I'm sorry, -2, -4. This is the origin, so it goes through the origin, back 1, 2, and then down 4. So -2, -4, it breaks down to 2. These are also points on the line, and every time you take your y and divide it by your x, look at the common number. You always are going to get a 2. That means that it is proportional. Where in this example, non-proportional, number 1, look at that. It does not go through the origin. And number 2, when I divide y by x, I get a different value each time. In this example, Janelle planted ornamental grass seed after the grass breaks the soil surface. Its height varies directly with the number of days. What is the rate of growth? So I want to notice my scale. I'm counting by one, so we'll kind of just stay with that. And I'm looking for a place where the line, notice it goes through the origin. That means it's going to be direct variation. And it's a line. So it goes here, and then that's a second point. So I want to use whole numbers rather than numbers that would be in between because I noticed this is 1.5. So I'm going to start at 0. I'm going to go up to 3. So that's my rise or my change in my y's over the change in my x's or 4. So k is equal to 3/4. And then that pattern continues. I'm always rising 3 and running 4. Rise 3, run 4. If you break this down into the ordered pair, there's two different ordered pairs here. So I've got this ordered pair would be 2, 1.5. And if I take 1.5 and divide it by 2, then I'm going to get 75%. Just like or 75 hundredths, which is 75%, or 3/4. They all are going to be equal to the same when you take an ordered pair and divide the y by the x. Our last example, the amount Dusty earns is directly proportional to the number of newspapers he delivers. How much does Dusty earn for each newspaper? So this is I notice on my y-axis, I'm counting by ones, but on my x-axis, I'm counting by 2s. That's really important to notice as you're counting. So these are all points on the line. I go up 1 and over 2, up 1 and over 2. I could also go up 2 and over 4, up 2 and over 4. Or I could go up 3 and over 6. Notice that those all break down to 0.5 or to 1/2. As far as the ordered pairs are concerned, this is an ordered pair. X is 2. Y would be 1, and look at that, y over x, and that's going to be k. So when you have the same k each time, then we have a constant of proportionality or a constant of variation. I hope you enjoyed your lesson on direct variation today. Last reminder that the graph always goes through the origin.